Working on the old Bard unit today. Let's figure out what the thermostat's set on. Make sure it's on cooling. Thermostat set to cooling. Cool on, should be running. There's the return. There's the supply. Sounds like the fan's running. Let's go outside and check it out. Okay, so this is 460 volt 3-phase. We got our gauges hooked up. We got pressure. Okay. So let's figure out why the compressor is not running. So looks like we got a head pressure control right here that's been cut. We got a low pressure control right here that's still wired up. Got our contactor, low voltage coming in. We've got a phase monitor. We've got a head pressure control, low pressure control, and this is a time delay relay control kit. So there's our power coming in. We got a little disconnect, a little breaker. Let's start from the beginning. Turn the meter on. All right. Get the leads. Fan's running, so we gotta have power, of course, so we don't have to check that, but we will check it just in a moment. First thing I'm going to do is I'm going to check right here, Y to C. Okay, Y to C. Okay, check my call. Okay, it says I got 27 volts. Right, 27 volts, because when I take it off, 0. So we got the call coming in from our thermostat from C to Y. We know we got our thermostat calling for the cooling operation. Now, where does this call go next? Okay, so this is the phase monitor right here. Monitors the phases. It's the safety control. And we got C and Y. So from this Y here, this wire, it goes into the phase monitor right here, okay? So if we take this wire out and measure from this C right here to this wire, we should have 24 volts going into the phase monitor. Let's do that now. Okay, so I am measuring from that Y. You'll see me put my meter lead right here on this C. Okay, what do I got? 27 volts. Okay, so we're going from here into the phase monitor. What's next? Well, we go out of the phase monitor, and we can see that right here. Oh, well, it just, oh, okay, well, it's working now. So I obviously reset the call going to the phase monitor. So, but what happens next? So we go to the Y out. Where does this wire go? It's yellow and looks like black. It goes right here. Okay, it goes into, and it says Y right there. It goes into this time delay relay control. So next we would check from the C to the Y going into this control. And then I'll go ahead and show you where it goes next. You see where it says CC? Okay, contactor coil, and then C down here, this black wire. Once you check from C to right here, if it's going there, then it goes through the high pressure control right there. There's a safety, and then you got your low pressure control. It's got to be closed as well, and then it's going to come out of the CC, and it's going to send voltage to the contactor coil. So we've obviously got an issue. Maybe we had an issue and our phase monitor picked up the issue, and then it had an alert. But usually there's a red light, and there wasn't a red light, there was a green light. So we obviously reset something. We've either got an issue that's caused this, or we could have a bad phase monitor or a control problem. So this part right here. All right, so I'm gonna go ahead and take my meter leads and show you how to check. Okay, and we can actually check from ground to this wire here. I'll show you where I'm at. I'm going to that Y, okay? So got that there. and checking from ground. And what do we got? 27 volts, because that C is connected to ground, so that's why I'm doing that. So we got voltage going from our phase monitor, it just kicked off again, to our delay control. Now we're going to check from the ground to the CC terminal, okay? Okay, checking from ground to the CC terminal. Now what do we got? 0, okay. So it's ending right there. Now I'm gonna do the same thing that I just did, which is I'm gonna take this wire loose, okay, from the phase monitor, and I'm gonna put it back in, get it to reset. Now, I'm gonna show you when it sends voltage from that CC terminal. Okay, I'm gonna check the CC terminal now. And this is what it's supposed to look like. Hope you guys can see that. It's kind of hard to... So 26 volts. All right. So we've got voltage now. Now let's check out our pressures. So there could be something wrong. The low pressure is 25. High pressure is 225. So what's happening is we are sensing an alert, an issue, and this module here, this control, is taking the call in, but it's not sending the call out because it's shutting down. Why is it shutting down? Because of this switch. This is a low pressure control, and we have low pressure. So we need to figure out where the leak is. We don't want to just charge the system. I'm going to go ahead and verify the voltage coming in, just for those of you that don't know how. This is how you do it. All right, from L1 to L2. Ah, come on now, what do you got? 502 volts. All right, from L1 to L3. 496 volts, and then from L2 to L3, 495 volts. There it goes, it just kicked off again. Now what we can do is we can actually check across this low pressure control from common to each side. Okay, I'm going to check one side, got 26 volts. Check the other side, 26 volts, but I guarantee you that there was no voltage coming through this switch. Okay, so really need to open this thing up, check for oil, maybe get my leak detector, maybe get some nitrogen. We will figure this out. Disconnect off. I'm going to open this up so I can get to the indoor coil. Go ahead and start with my leak detector and then visually look and see if I can find any sign of any oil. Got the panels off. You can see the indoor motor. You can see the indoor coil up here. And I got this panel off too. So you can see the condenser fan. You can see the coil. See how dirty it is. All right, I'm gonna get my leak detector first. All right, wind's blowing pretty heavy. I'm gonna check the indoor coil first. That's usually where you find the leaks. In the same spots. Yep. We got a leaking indoor coil. If you ever have to replace one of these blower motors on these barred units, it's not that hard. There are only a few screws that hold that housing in place. It's easy to get out, but it can be a little bit harder when the barred unit is high up off the ground and you have to be on a ladder. Let me show you the screws that hold that housing in place. So you can see We got this little bracket here and this little bracket. The housing just slides right in. All you have to do is just take this off, okay? So you got 1, 2, 3, 4, 5, 6, 7, 8, 5/16 screws. You take those loose, and then you can probably just cut the wire right here, wire nut it back together, or come right here, find where the wires go, and then you can just take them all out. Just make sure you know exactly where they go. You can see some of the speeds are not being used for that blower motor. You've only got a yellow wire going to one side of the power, and then a black wire going to this relay. This is a relay that controls that blower. So we got a little blower relay there. But they do go bad, and you can see a little bit of oil from this motor. So just want to show you that. Got our filter access door here, and then got a couple screws in this still. Oh, got an economizer. Nice. So this has an economizer, and that helps to provide free cooling. When the air is cool enough outside, you don't have to run the compressor, then that will open up a damper. And this must be a outdoor air sensor that's connected to it. Maybe a combo humidity air sensor. So interesting. But there's where the filter is right there. Okay, so we got most of the panels back on. I have to charge this because they need this to cool the pumps inside, which I'll show you in a moment. So I got my clamp, the meter, I've got my scales, and I'm ready to put some more 410A in this system. So without further ado, let's get it kicked back on and start charging. Show you why we got to keep this little building cool. Our city's water depends on it. We got these pumps, we got these controls that drive the pumps, we got a transformer. So it's critical that we keep this building cool, especially when it's 85 degrees outside. Oh, unit just kicked back on. Zero out the scales, already bled the line. We're gonna add some refrigerant. It's 25 and 225. Sure that's closed. We got 5 ounces already. Ooh, our head pressure is climbing. I'm gonna go ahead and shut this down. It's about 12 ounces right now. Suction line temperature 70, 69. Ooh, that is not good. Still need some more refrigerant. 45 and 265. Oh yeah, we definitely need some more. So we're gonna add some more refrigerant. We'll check it here in a minute. Look at that head pressure going up. I mean, it's hot in there right now, so I can expect that head pressure to be about 350. Well, it's not too hot. It's only 75 in here right now. But it's early in the morning, so that's why I'm sure as the day proceeds on, it'll probably become scorching hot in there. Okay, let's see what we got. So we've added 2 pounds, okay? 2 pounds of 410A. Head pressure is now 335 and 100 for the vapor pressure. Suction line temperature now is 62, so that's awesome. We've added 2 pounds of 410A. Head pressure is about 335. Suction is 100, so we're getting close to being charged now. Look at that, 61. Oh, low battery. Okay. Let's go over the schematic. For those of you that need to learn more about reading schematics, you've got your low voltage wiring here. Let's go over the secondary of the transformers right here. We've got our C and our R. That makes our 24 volts. So you can see how the C is connected to the ground. Right there, that means ground. This side is R, so red. And then if you follow this line down here and over, that's C. So C and R, 24 volts. Now, that C goes to the time delay relay control right here, low pressure control, high pressure control, and then it goes to one side of the compressor contactor coil. So all we need is the Y to connect to the other side, and then that coil will energize and it'll close these contacts, therefore sending power to the compressor. Now let's go back here. If we measure from C to Y, we should have 24 volts. Then we go to the phase monitor, and then we go from the phase monitor, see it says Y out, to this Y, which is the time delay relay control. If the high pressure control, the low pressure control is closed, then this little module or control should send power. And that Y should go through here, here, and then through here. See how there is a normally open set of contacts? That closes, and then you have your Y going through those contacts, or that power going through that contact to that coil of that contactor. And then boom, compressor contactor should close the contacts, and then boom, we got power. And you can see right here, we got our indoor blower relay. We looked at that earlier. This is our 460 volt coming in. Phase monitor L1, L2, L3. Okay. So we've got 95 and about 235, and we're gonna add some more refrigerant. We've only got 2 pounds, so add a little bit more. Then we're gonna check and see where we're at. It's 2.5 pounds. I think we're gonna stop there. Oh, just shut off. Let's go check the thermostat. Wow, it's already reached temperature. That's excellent. Okay, turn it back down so we can make sure that charge is right. Unit kicked back on. This unit only holds 69 ounces, so it's a little over 4 pounds. And we put 3 pounds in this thing, so it is leaking, definitely leaking bad. So we've got 105 and about 360. And what does my meter say? Okay, got a good suction temperature now. 57, 56. Okay, 55. Okay, so it's 54. So okay, we've hit the sweet spot. This line is nice and cool now. Oh wow, yeah, we've definitely hit the sweet spot. 41. Okay, excellent. So if we look at 41 and about 35, that's 6 degrees of superheat. So let me turn this back on. I gotta replace the battery in this thing. So 45, so we got a good superheat. I'm gonna say this unit is pretty well charged. 350 on the head, 105 on the suction, 48 on the suction line temperature. We've added almost 3 pounds, and 48 and about 35, that's about 12 degrees of superheat. So our superheat's pretty good. It's jumping around right now. Okay, good. Unit's charged. Get a price on the coil, get a price on the new barred unit, go from there. It's a 3-ton barred unit, 36,000 BTU. Don't forget to turn the thermostat back up. We don't need it 66 in here. So I got it on 70. What is it going to cost to repair? What is it going to cost to replace? Let's talk about that. Also, let's go over the purpose of the phase monitor and the time delay relay control, and talk a little bit about our diagnosis today with this barred unit. I hope you enjoyed watching this, and if you do want to watch more videos about working on barred units, I'll drop a couple videos down the link in the description. So I got a price on the replacement of the barred unit, which is a direct replacement. So if they do go with this, which I hope they do choose this path, but if they don't, I'll tell you what I'm going to do with the repair to make sure the equipment lasts as long as possible. The price on that barred unit replacement is about $9,000. It'll take us less than 4 hours. It's a direct replacement. The only thing we'll be replacing with that barred unit is maybe some conduit, some new wiring, maybe a new breaker or fuses, if there are fuses in that disconnect beside the barred unit. But if they don't choose the replacement, that's okay. The repair is going to cost around $2,000 for repairing that evaporator coil. And I'm going to make sure that I install a new filter dryer. new refrigerant. I clean the outdoor coil, that condenser coil. And then I am going to look at all the relays, like that blower relay that had those rusted contacts. I'm going to make sure I replace that 9340 relay that I showed you in the video. I'm going to look at the contactor coil. The contactor contacts, and see if they are pitted, see if there's carbon buildup, and I'm going to replace anything I can in there that's small, maybe capacitors, check all those. That way, when I do this repair, I make sure that it lasts as long as possible before we get the next call on this. So that's my advice to you. If you do end up having a customer choose the repair option, do whatever you can to make sure that you're not going back. I've got videos where I replace heat exchangers, but with that heat exchanger, I replace the burners, the limit switch, the rollout switch, and anything I could find that had corrosion or rust that I thought may be a callback area. I don't want to have callbacks, especially when they choose to repair. So I typed up my quote today. I sent the proposal. I gave them 2 options because I'm only here to give options and to help. Now let's talk about the phase monitor. The phase monitor is monitoring the phase. So if a phase drops and we only have 2 lines of power going to that phase monitor, it's not going to allow that contactor coil to be energized, because it's not going to send voltage to the time delay relay control, because that was the next step when we looked at our process of elimination earlier, when we were going through there trying to figure out where our voltage was getting to as far as the cooling call and where it was not getting to. So that phase monitor is there to protect that compressor motor, and any time that it does not sense the proper voltage, the proper phase, then it is going to stop that cooling call from going to the next control, which is the time delay relay control. And this little wonderful module or control, whenever that low pressure control was opening, that pressure switch was opening because we didn't have the right pressure, then that time delay relay control was not closing the contacts and energizing the circuit for the CC terminal to send that voltage onto the contactor coil to energize that coil, because we don't want to energize that compressor coil when we have a low pressure control or head pressure control that is open, because we're going to end up damaging components. So we were able to find out that, hey, it's stopping right here. We don't have any voltage at the CC terminal from common to CC, which is our CNRY, our call for cooling. And this is our problem area. So I hope you enjoyed today's video. If you want to learn more about BARD units, again, I've got a couple videos working on BARD units. If you want to learn more about charging using superheating and subcooling, what that is, how to charge an air conditioner, drop a couple videos down there on that. I really appreciate you watching. Hit the like button, subscribe, and smash that bell, ding, so you know what I'm doing. You're watching HVAC Tips for Technicians. I'm Tad, and I'll keep you cool if you let me.